In this video, we are going to solve few numericals based on various properties of Fourier transform. So with the help of these properties, these questions will be solved very easily. Although these questions can be solved without using the properties, but then it will be somewhat lengthy. And if in the exam they will ask to calculate the Fourier transform of sin omega naught t, it is up to you to solve either with the help of property or without the help of property. So both ways you can solve it. They will not mention that you have to calculate or you have to solve the Fourier transform with the help of some properties. So with the help of some properties, we will solve various questions in the series of that. First question or first problem is Fourier transform of sin omega naught t. So first of all, sin theta can be written as e to the power j theta minus e to the power minus j theta upon 2j. This is a trigonometric identity. So on the basis of that, sin omega naught t is e to the power j omega naught t minus e to the power minus j omega naught t upon 2j. So again this thing can be written as 1 by 2j e to the power j omega naught t minus 1 by 2j e to the power minus j omega naught t. So if you want to calculate the Fourier transform of sin omega naught t, you can calculate the Fourier transform of 1 by 2j e to the power j omega naught t minus Fourier transform of 1 by 2j e to the power minus j omega naught t. So that means both the parts Fourier transform can be calculated separately. So now come to the first part, Fourier transform of constant A. In my previous video, I have already calculated the Fourier transform of constant A, which was 2 pi a delta omega. So those who don't understand that how this Fourier transform of constant A came, you can see my previous video in which I have explained how the constant A will get the Fourier transform 2 pi a delta omega. So those who have already seen the video, they know already that Fourier transform of any constant is 2 pi a delta omega. So in this 1 by 2j is a constant, so instead of a I have put 1 by 2j. So 2 pi into 1 by 2j delta omega, 2 and 2 will get cancelled, so it will be pi by j delta omega. That means Fourier transform of 1 by 2j is pi by j delta omega. So now this is this 1 by 2j can be considered as a function ft into e to the power j omega naught t. Here I am using frequency shifting property. Frequency shifting property says that ft into e to the power j omega naught t has a Fourier transform f of omega minus omega naught. Similarly, ft into e to the power minus j omega naught t will be having Fourier transform f of omega plus omega naught. So again, this frequency shifting property I have explained in my previous video where various properties of Fourier transform is explained. So this is the statement of frequency shifting property. So if ft is multiplied with e to the power j omega naught t, here 1 by 2j can be considered as ft, it is multiplied with e to the power j omega naught t. So whatever the Fourier transform of this, it will be shifted by omega minus omega naught with negative sign in this part and with positive side in this part. So we have already calculated the Fourier transform of 1 by 2j, which is pi by j delta omega. So Fourier transform of sin omega naught t will be pi by j, and delta omega, it will be shifted with negative sign, so delta omega minus omega naught, here delta omega plus omega naught. Again in this equation, if I multiply and divide with j, it will become j pi and this will become j square. J square is minus 1, so that means this part will become negative and minus will become plus, so this part will become positive. So numerator you are having a j, so that means j pi delta omega plus omega naught minus j pi delta omega minus omega naught. This is the Fourier transform of sin omega naught t. I hope you understand. If not, if you have doubt in this section or this section, you can watch my previous videos related to various properties of Fourier transform and related to Fourier transform of various predefined functions. In the next numerical based property question, I will take cos omega naught t. So the next problem is cos omega naught t. As the trigonometrical identity, cos omega naught t can be stated as e to the power j omega naught t plus e to the power minus j omega naught t upon 2. In the sign it was negative and in the denominator it was 2j, whereas in cos the values are added and in the denominator you are having only 2. So this is the conversion of cos omega naught t in the form of exponential as per the trigonometric identity. So it will be now 1 by 2 e to the power j omega naught t plus 1 by 2 e to the power minus j omega naught t. So Fourier transform of cos omega naught t will be Fourier transform of this plus Fourier transform of this. Fourier transform of 1 by 2 is nothing but 2 pi into 1 by 2 delta omega. That means I have kept instead of a 1 by 2 because Fourier transform of constant a is 2 pi a delta omega. So it will be pi del omega. So that means pi del omega will be the Fourier transform of 1 by 2. Again, by applying frequency shifting property, ft into e to the power j omega naught t will get f of omega minus omega naught. So the first part will be pi del omega minus omega naught, pi del omega plus omega naught. This is the Fourier transform of cos omega naught t by using the properties of Fourier transform. Now next question will be a shifted gate function. So let's see how shifted gate function will get the Fourier transform using the property. So next function is a shifted gate function. Something of this sort will be asked in the exam and they will ask to calculate the Fourier transform of the given pulse. So just by viewing the given pulse you will get confused or you may get confused, but if you remember or recall our gate function, those who have already seen my video of gate function, they will be easily recalling this particular thing. This is a gate function. Gate function is nothing but a rectangular pulse of specified width and height. So this is a gate function. Now just see, if I am pushing this gate function from left to right, if by pushing I will push this point towards the origin, it will be something like this. That means minus tau by 2 will be having value at 0 and tau by 2 will be shifting to tau. So this is a shifted gate function. So this is, you can see, have some similarity where tau is equals to 2 and a is equals to 10. So this is nothing but our shifted gate function. You know the Fourier transform of gate function, which is a tau sampling of omega tau by 2. So if I shift this gate function, if this is denoted by g of t, this can be denoted by g of t minus tau by 2 because I have shifted this gate function by how much value? Tau by 2 value. So this will be nothing but g of t minus tau by 2. So the Fourier transform of this will be a tau sampling of omega tau by 2, which is the Fourier transform of gt, and this shifted thing will be shifted in the exponential term, which is e to the power minus j omega tau by 2. So just for the reference, by time shifting property says that f of t minus t naught will be having Fourier transform f omega e raised to the power minus j omega t naught. So similar ways I have shifted this t naught in the exponential term where t naught is tau by 2 in this case. So as far as this case is concerned, your value of a is what? 10. Your value of tau is what? 2. So 10 into 2 sampling of omega 2 by 2 e to the power minus j omega 2 upon 2. So 2 and 2 will get cancelled. So the final answer will be 20 sampling of omega e to the power minus j omega. This is the answer of this particular pulse. So by using this property, you can easily calculate the Fourier transform of the shifted pulse. So this is based on time shifting property. Previous question was based on frequency shifting property. Now we will see the questions based on duality properties. So next we will see the numericals based on duality property. So the question may be asked in the exam in this manner: find inverse Fourier transform of signum omega and del omega using duality property. So what our duality property says that if ft has a Fourier transform f of omega, then 2 pi f of minus omega has a Fourier transform ft. So for that, in place of ft, first we will put signum t. Signum t has a Fourier transform 2 by j omega. This we have already calculated. You can see my previous videos. So signum t has a Fourier transform 2 by j omega. So now applying the property, it will be 2 pi signum of minus omega. That means f of t will be replaced by f of minus omega. That means signum t is replaced by signum of minus omega. And here f omega, that means the Fourier transform omega is replaced with t. So in this right hand side, omega will be replaced with t, so it will become 2 pi jt. So this is 2 pi, signum of minus omega has a inverse Fourier transform 2 by jt. So signum of minus omega has a Fourier transform 2 upon 2 pi. I will take here 2 pi jt, 2 and 2 will get cancelled, so it will become 1 upon pi jt. Now signum of minus omega, f of minus x is equals to minus of fx, and f of minus x is equals to fx. These are the two mathematical conditions. If the function is an even function, this will be there. If the function is odd, it will be there. So signum function is an even function, so that is why signum of minus omega will be minus of signum omega. If the function is odd, signum minus omega or any function f of minus omega will become minus of f omega. So it is minus signum omega 1 by j pi t. So signum omega will be minus sign I will take here, that is minus 1 upon j pi t, as signum is an odd function. Similarly, I will see del omega. So you know that delta t has a Fourier transform 1. So 2 pi delta omega has a Fourier transform, inverse Fourier transform 1. So again del minus omega 2 pi I will take here, it will be 1 by 2 pi. Now again this delta omega is an even function. So del of minus omega will be del of omega. So del of omega has an inverse Fourier transform 1 upon 2 pi. So this is the inverse Fourier transform of del omega, and this is the inverse Fourier transform of signum omega with the help of duality property.